Now the next type of enthalpy we need to understand is the enthalpy of solution. See, it's the amount of energy released or absorbed when 1 mole of a substance is completely dissolved in what? In excess or in large amount of solvent. So it's the amount of energy released or absorbed when 1 mole of a substance is completely dissolved in the solvent is called the enthalpy of enthalpy of the solution of that particular solute. So we mainly talk about this enthalpy of solution particularly for the ionic compounds. Let us take this example of NaCl. When this solid NaCl is actually added to water, we know that it changes to Na plus ions aqueous and Cl minus ions aqueous. So it is the amount of energy released when 1 mole of the substance is completely dissolved in solvent is called the enthalpy of solution, or it is the amount of energy released, like in this case of sodium chloride, when 1 mole of sodium chloride is dissolved in water. Now this enthalpy of solution, the energy involved in this is of course is enthalpy of solution. The symbol is, we write it either the complete solution word in this or we write SOL. Now in this process, 2 steps are involved. The first is the crystal lattice of this ionic solids, the crystalline lattice of these ionic solids is broken down actually into the individual ions. In this case, what we get is basically is Na plus gas and Cl minus gas. Now in this, the energy involved is called lattice enthalpy. We call this as lattice enthalpy. And then these are actually added to water, so that what we get is, the second step is that we put them in water and the energy involved is called enthalpy of dissolution. Basically, it is the enthalpy of dissolution we call it. This enthalpy of dissolution, we call it normally the enthalpy of hydration. It means what? When these ions are actually added to water, they get hydrated or solvated by the solvent molecules so that they become stable, and then we reach to this situation of aqueous medium. So this enthalpy of solution, remember, is always the sum of lattice enthalpy and the hydration enthalpy of that particular salt. And lattice enthalpy, usually we know that this data is obtained from Born-Haber's cycle, which actually give us the Bailey is studied, which is an application of the Hess's law, and it is mainly done in order to find out the enthalpy of lattice enthalpy of particular crystalline solid and then hydration enthalpy. And even if we know these enthalpy of solution, yes, we can find out the lattice enthalpies data and the hydration enthalpies data for any of the substances. Also, we need to know higher is the lattice enthalpy, that means more stronger is your ionic solid. So what will happen is more amount of energy is required to break the crystalline solid from its ionic crystalline state to the individual ions, and more is the hydration enthalpies. It means what? The smaller is the sizes of the ions. That is why the more the water molecules or solvent molecules are attracted by these particular ions, and more amount of energy is being released. What is most important is the enthalpy of solution usually has to be negative in order to make a substance soluble in water or any particular solvent. And therefore, the hydration enthalpy, which is usually is negative because that's the amount of energy released. Lattice, which is usually it is positive because that is the amount of energy which is given. So what does it indicate is that hydration must be higher than lattice enthalpy.